Good morning, everyone. Myself, Nimita Mansikia, Assistant Professor in the Department of Electrical and Electronics Engineering. In this semester, I'm handling EE 3017 MWC programming in the Regulation 2021. In today's, we are going to study one of the most important interfacing techniques in embedded system called ADC interfacing. This ADC stands for Analog to Digital Converter. In a real world application, many sensors such as temperature sensor, light sensors, pressure sensor, humidity sensor, it produces the analog signals. So since microcontrollers like 8051 can understand only the digital data, such as zeros and ones, so we need an ADC to convert analog signals into digital form. So we are having this ADC interfacing. The main the topic focuses on ADC 0804 and it is how it is interfaced with the microcontroller. The objectives, what we are going to see in today's session is what is the ADC, what is the analog to digital converter, and the pin diagram of ADC of 0804, and the pin description of ADC and the interfacing diagram, how it is working, and what is the timing diagram, and what is the introduction of ADC 808 or 808 or 0889. And then what is ADC? Now, already I told you know what is mean by ADC. ADC means analog to digital converter. So it converts the continuously varying analog voltage into the equivalent digital number. So if we are having the analog voltage that in a form of a waveform, so it will be converted into in a digital form, that is zero point 0.5 volt, 0 volt. That time it will convert into analog to digital converter. Suppose the temperature sensor gives 0 volt for 0 degrees Celsius, then 5 volt for 100 degrees Celsius. So we are having the approximate accurate voltage for the analog formation. If the sensor output is 2.5, the ADC converts this voltage into a digital value as 128 because 5 volt for 100 volts. Then the 2.5 volt is the half of it, then that's a 50 degrees Celsius. So this is the meaning of that conversion process and why we need ADC. ADC is a very important thing. The microcontrollers can process only digital data, but most sensors generate analog outputs. So if we are having the analog outputs, we can't able to find what is the value of the value of the output. So we are having the ADC because it converts the analog output into the digital format. So most sensors generate analog output. Therefore, ADC acts as a bridge between that sensors. So analog world means it's a sensors and the digital world means it's a microcontroller. So because of the microcontroller, we are receiving output as a digital world. Next, the application is what are the application we are using is in it's a digital thermometer and it's used for a battery monitoring. Next one, we are using this ADC into the medical instruments, industrial automation, and robotics also. So we are having the different kind of application in this, and we are also having the ADCs are widely used whenever the analog data must be processed or stored or transmitted. Whatever it is, the ADC are widely used because, for example, in TV tuner cards, in data acquisition system, we are using the ADC, and also for the weather monitoring also we are using this. The two commonly used ADC in microcontrollers, zero ADC 0804, that is a single channel. So that we are having that ADC 0804 and the ADC 0808 and or ADC 0809 is the 8 channel. So these two commonly used ADC chips in the microcontroller. In session, we are discussed about the ADC 0804. Uh, in this ADC 0804 is a 20-pin microcontroller. So it's a 20-pin microcontroller in 8-bit parallel ADC. So you having the 8-bit parallel ADC and it is works on the principle of it operates with a plus 5 volt. These are the key characteristics. So we are having the 5 volt operate ADC 0804 and it have a single analog input channel. This is the nothing have a This is having a single channel. In 0808 is an 8 channel. So, but in 0804 it has a single channel input channel, single analog input channel, and we're having the 8-bit digital output. The output must contain the 8-bit digital output, and it's also having the on-chip clock generator, and it's a parallel data output. So approximately 110 microseconds, that it means converts analog input into digital output very quickly. So it approximately takes 110 microseconds only. Then the features of ADC of 0804. So the important feature is that it has 8-bit resolution. What are the resolution? 8-bit resolution means the digital output ranges from 0 to 1. That is 0000, the 8 bits of 0 and to 8 bits of 1s. That is the value of 0 to 255. So the output can represent the 256 different voltage levels. So whatever the voltage level must be, it must be ranges in between the 0, that is 8 zeros to 8 1, that is 0 to 255. So it represents 256 different voltage level. And the next one is the conversion time is 110 microsecond. Already we discussed, no. So it converts into analog to digital. It converts within the 110 microseconds. And the access time is 135 nanosecond. That is very less time taken for the access time. And it has a built-in clock generator. So this microcontroller is always have a built-in, the clock generator is built-in. So no zero adjustment needed. So we can't do, we should not do any adjustment. So it having a built-in clock generator means, so it require, if it require any adjustment, now it will make a adjustment for the microcontroller. And it have a single 5-volt supply, and it is the TTL compatible outputs. So TTL means it's a 0 to 5 volt only. So having the compatible outputs. Then the resolution calculation. How to find the resolution calculation? The resolution of an 8-bit ADC is what is the voltage reference? Here voltage reference is 5 volt divided by 2 power 8 because it's a 8-bit. So we have to mention it in the 2 power 8. So the voltage reference is 5 volt, and it having a 8-bit ADC. So 2 power 8 is 256. So the resolution time is 19. The 5 volt divided by 256 is equal to 19.53 millivolt. This means every increase of approximately 19.53 millivolt changes the digital output by one count. So the digital output, it's changes by one count means it takes approximately 19.53 millivolt. This is the pin diagram of ADC 0804. The important pins is this V in pin, that is the 5 volt uh, analog input, and the D0 to D7. This is D0 to D7, the DD0 to D07. That is the digital output. And the CS, this is the chip select, how, which chip we have to select. And WR is the start conversion, and RD is the read data, and INTR is the conversion complete signal. This is the conversion complete signal, this INTR. And the clock in and clock out is the clock pins. Clock in, CA, clock in and clock out. These are the clock pins, and VCC and ground may be the power supply. So these are the pin diagram, and this is the interfacing diagram. What is meant by CS? This is having a, we are having the ADC 0804, and it's a 8051 microcontroller. Already we have discussed about the 8051 microcontroller. Just we are interfacing this 8051 microcontroller with the ADC 080704. So we are clearly explain the what are the pins and what the pins are doing. The CS is the chip select. So it activates the ADC when set to 0, and WR is start the on conversion process. And RD means it's a read, then it reads the converted digital data. INTR means it's the interrupt. It goes slow when the inversion is complete, conversion is complete. If we are convert analog to digital data, digital output, if the conversion is complete means this INTR goes slow. If the INTR is high, the conversion does not complete. It shows that the conversion is in the process. Oh, okay. So then D0 to D7, that is the digital output. No, it carry the 8-bit. 0 to 7, it carry the 8-bit digital output. This is the interfacing diagram. This analog signal is applied to the VIN. Here the VIN supply, that's 5 volt, is applied to the VIN, and the D0 to D7 are connected to the this D0 to D7 are connected to the port 1 of the 8051. So port 1 to 7 we are having the port 1, 0 to 7 we are connecting this 8051 with the ADC. Then CS, WR, RD and INTR are connected to the control pins. So first the sensor will send to the ADC 0804 and which is given to the microcontroller 8051 and which displays the LCD displays. The working of this is the working. In this working, we are having the interfacing initialization is needed so that we are having the 8051 microcontroller and ADC 0804 should be interfacing. For ADC, the initial values are the initial values that is the INTR is equals to 1, read equal to 1, the write equal to 0. That write equal to 0 means it start conversion rate. So these initial values prepares the ADC for conversion. So next, having the starting conversion, to start conversion, making CS is equals to 0. So we have to select the chip select is equals to 0. Give a low to high pulse on the right. We are here we note it right is equal to 0. So we give a low to high pulse to the right. So we are giving the right is equals to 1. This pulse tells the ADC start converting the analog voltage. So analog voltage starts converting. So next, what the after conversion starts, INTR remains high while the conversion is in progress. Already we told no, this INTR point is high means the conversion is in progress. INTR becomes low means the conversion is complete. That is the analog to digital conversion should complete. So the INTR becomes low, the conversion is complete. The microcontroller continuously checks INTR. Okay. When INTR becomes low, after the conversion is complete, the INTR shows low. Keep CS, that is chip select is equal to 0. Give high to low pulse on the read. Here read is equals to 1 means we have to select read equal to 0. Read the 8-bit data from D0 to D7. So the digital value is now available to the microcontroller. So the complete working series, first we are having the apply the analog voltage, then set CS is equals to 0, then pulse WR, wait for the INTR signal, then pulse read. First we have to pulse the write signal. The write is equals to 1, wait for the INTR. When the INTR becomes 0, we are giving pulse to the read. What it gives the low to high, sorry, high to low, then it becomes the read to D0 to D7, then the process it display the result. So the example conversion is the reference voltage is if we are giving reference voltage is 5 volt, the input voltage is 2.5 volt, means what is the digital output? The 2.5 divided by reference. So 2.5 divided by 5 into 255. What does mean by 255? We are having the values no 0 to 255. 8 zeros to 8 1. That is 8 1 is 255. So we are having the approximate value is 128. So we are write the binary equivalent of this diagram. So that this timing diagram shows when right pulse is given, the duration of conversion, INT are going low, when the RD pulse to read data. So this understand the exact sequence of the signals. Next, having the advantages of the 8008 and the 0809 are the advanced CS with the 8 channel of input channel. So here we are using the multiple sensors can be connected and having the internal multiplexer select so one channel at a time. So the application is the data acquisition system, the multi-sensor monitoring. These are the applications of this 0808 and 0809. And the real-time applications are also there. That is a digital thermometer, ECG machines, solar power monitoring, robotics, smart agriculture. These are the real-life applications are also there. These are the references and we will see in the next topic. Thank you.